students. Today's class is about probability. So let's say we have an event E, be an event. The probability of E is number of favorable cases or outcomes divided by the total number of outcomes. So let's suppose if you throw a die, the outcomes are possible outcomes are 1, 2, 3, 4, 5 and 6. So there are 6 total number of outcomes, and if let's say E be an event of an odd number, getting an odd number while throwing a dice. So what are the odd numbers here? 1, 3 and 5. So we have 3 favorable outcomes. So probability of E is 3 by 6, which is equal to 1 by 2. Now let's see about the types of events. There are various types of events. We'll talk about independent events, the events A and B are said to be independent if the occurrence of A and B does not affect each other, like getting a odd number and even number on a die, on throw of 2 dice does not affect each other. You can get an odd number on the first die and an even number on the second die. It doesn't affect each other. So in that case, the probability of A intersection B is always equal to probability of A multiplied by probability of B. So in case of independent events, the probability of A intersection B is always equal to probability of A multiplied by probability of B. Then we have mutually exclusive events. What do we mean by mutually exclusive events? If occurrence of one event rules out the occurrence of another event. If we have an event E saying getting head on a flip of a coin, flipping a coin, and F be an event of tail, getting tail on flipping a coin. So if E happens, then F cannot happen. So if you are getting head on flipping a coin, you cannot get a tail on that same coin on that very event. So these two are mutually exclusive events for flipping a coin once. Because if you are flipping a coin at once, so you can either get a head or a tail. You cannot get both head and tail. So that's why they are mutually exclusive events. So and even E intersection F is always equal to phi for mutually exclusive events. So this was about mutually exclusive events and independent events. Then we have exhaustive events. A set of events are said to be exhaustive if the performance of any random variable always results in the occurrence of at least one of those. Like if we have a set of events E1, E2 till En, and I am having some random experiment. So if my E1 union E2 union En is equal to S, the sample space, then E1, E2, En are the exhaustive events, because if the random experiment is occurring and you are getting any outcome, then it must belong to any of these sets. Now let's see the probabilities of some, like probability of any phi is always equal to 0. and the probability of the complete sample space is always equal to 1. Let's see some formulas. Probability of A union B is equal to probability of A plus probability of B minus probability of A intersection B. The next is conditional probability. Suppose you know that you have to find the probability of occurrence of event B and you know that event A has already been occurred. So we have to find the probability of occurrence of the event B, and we are been given that the event A has already been occurred. So in that case we write it as probability of B given that A has already been occurred. And what is the formula for this? It is equal to probability of A intersection B divided by probability of A. So when we have to find the probability of event B when A has already been occurred is probability of A intersection B divided by probability of A. The next one is total probability theorem. What does the total probability theorem is? Let's say you have an event A be an event. You can write it A as A1 intersection A union A2 intersection A union AN intersection A, where A1, A2, AN are mutually exclusive events. Are mutually exclusive, and union of A1 union A2 union AN makes up A. So if we take events like A1 A2 union AN, that makes up A, and they are mutually exclusive, then A can be written in this form. Now the probability of A will be equal to probability of A1 intersection A plus probability of A2 intersection A plus probability of AN intersection A. Since they are mutually exclusive A1, A2, AN, so that's why A1 intersection A, A2 intersection A, AN intersection A will also be mutually exclusive, and thus this probability of their union is the summation of the probabilities. Now probability of A1 intersection A can be written as probability of A given A1 multiplied by probability of A1. As we have seen that probability of A given A1 would be probability of A intersection A1 divided by probability of A1. So from this we can conclude that probability of A intersection A1 is equal to probability of A given A1 multiplied by probability of A1. So same thing we have used here, and we can write it for all AIs as probability of A by AN multiplied by probability of AN. So it is equal to summation I equal to 1 to N P of AI multiplied by P of A given AI. So this is the total probability theorem, that if you have an event A which is divided into sub events A1, A2, AN which are mutually exclusive and their union is A, then probability of A can be written as this. Now if you have to find the probability of the event AI when A is already been occurred, then you can find it using the formula P of AI given P of AI multiplied by P of A given AI divided by P of A. and here P of H is same as summation I equal to 1 to n P of AI multiplied by P of A given AI. So if you have to find for any I, any particular I, say A1 or A2, the probability says that AI given A, then it's P of AI multiplied by P of A given AI divided by P of A. This is the Bayes theorem. States that or Bayes theorem. Now let's discuss some questions. We have a number x is chosen at random from the set 1, 2, 3, 4 till 100. Define the event A such that the chosen number x satisfies x minus 10 multiplied by x minus 50 divided by x minus 30 has to be greater than equal to 0. Now we have been given the expression x minus 10 multiplied by x minus 50 divided by x minus 30 is greater than equal to 0, right? So if we draw a number line and mark the points 10, 30 and 50, 10, 30 and 50. So if x is less than 10 and we have the limit from 1 to 100, so this is 1 and till 100. So if we see from 1 to 10, x is between 1 to 10, let's say 5, then 5 minus 10, this is negative, this term is also negative and this is also negative. So we get a negative sign here. When from 10 to 30, let's say we take 15, this is positive, this is negative and this is negative. So we have two negative terms and one positive term. So it will become positive. At x equal to 30, the statement is not defined because the denominator is getting 0. So we ignore this point, cannot take x equal to 30. And when between 30 to 50, let's say it's 35, this is positive, this is negative and this is positive. So we get a negative. And from 50 to 100, let's say at 60, all of them are positive. So we get a positive. Now we want it to be positive, greater than equal to 0. So x can take value between 10 and 30 and 50 and 100. So how many integers are there between 10 and 30? Including 10 and excluding 30. So we have 20 integers. And between 50 and 100, we have 51 integers, including both 50 and 100. So we have 51 integers. So x can take total 71 integers. These are the favorable outcomes. And how many integers do we have in the set? So total outcomes are 100. So probability is 71 by 100, which is equal to 0.71. So this is the correct answer. Now the next question is, if A and B are any two events such that probability of A is 2 by 5 and A intersection B is 3 by 20, then the conditional probability of P of A given A complement union B complement, probability of A given A complement union B complement. Now it will be equal to probability of A intersection A complement union B complement divided by probability of A complement union B complement. Right. Now if we use the De Morgan's law, which states that A dash union B dash is equal to A intersection B whole dash. Right, so probability of A dash A complement union B complement is equal to probability of A intersection B complement, which is equal to 1 minus probability of A intersection B. Right, because probability of A complement is always equal to 1 minus probability of A. So it is 1 minus 3 by 20, which is equal to 17 by 20. So we get the denominator equal to 17 by 20. Now we have to find the numerator, which is A intersection A complement union B complement. So it is equal to probability of A intersection B complement. If we draw the Venn diagram, if we have A like this and B like this, we have A intersection with B complement is this region. So probability of this region is nothing but probability of A minus probability of A intersection B. The probability of shaded region is this. So probability of A is 2 by 5 minus 3 by 20, which is equal to 8 by 20 minus 3 by 20, 5 by 20. So it is equal to 5 by 20 divided by 17 by 20. So the answer is 5 by 17. So the answer is 5 by 17. Here we have a next question. For 3 events A, B and C, probability of exactly one of A or B occurs is same as probability of exactly one of B or C occurs is equal to probability of exactly one of C or A occurs, and it's all these 3 probabilities are equal to 1 by 4. And we have been given that the probability of the occurring of all the 3 events A, B, C simultaneously is 1 by 16. And we have to find the probability that at least one of the event occurs. So at least one of the event occurs is probability of A union B union C. Okay, so we have to find this. All 3 occurs is probability of A intersection B intersection C. So we have been given 1 by 16 as probability of A intersection B intersection C. Exactly one of A or B occur is probability of A plus probability of B minus twice probability of A intersection B. How do we get this? If we draw the Venn diagram, you have A and B. And exactly one of A or B occurs. Both cannot occur. So we want the probability of this region and this region. So if we add probability of A and probability of B, this region is added twice. So we have to subtract it twice to get the probability of the shaded region. So this is this, which is equal to 1 by 4. Probability of exactly one of B or C is probability of B plus probability of C minus twice of probability B intersection C, which is also equal to 1 by 4. And same in this case, probability of C plus probability of A is equal to minus twice probability of A intersection C is equal to 1 by 4. Now if we add these 3 equations 1, 2 and 3, what do we get? Twice of probability of A plus probability of B plus probability of C minus P of A intersection C minus P of B intersection C and minus P of A intersection B is equal to thrice of 1 by 4, 3 by 4. Now from this, what do we get? We get that P of A plus P of B plus probability of C minus probability of A intersection C minus A intersection B. Now probability of B intersection C is equal to 3 by 8. As this 2 will be multiplied by 4, so we get 3 by 8. Now we have to find the probability of A union B union C. So what is the formula for P of A union B union C? It is this thing plus probability of A intersection B intersection C. So it is 3 by 8 plus 1 by 16, which is equal to 6 by 16 plus 1 by 16, which is same as 7 by 16. So the probability of occurring of the at least one of the events is 7 by 16. So we have a next question. States that an unbiased coin is tossed 8 times. So we have been tossing a coin 8 times. The probability of obtaining at least one head and at least one tail is. So we need at least one head and at least one tail. So if I subtract the probability from one of getting no head and probability of getting no tail, then I'll get the probability of this. Probability of at least one head and one tail is equal to 1 minus probability of no head minus probability of no tail. Now the total number of outcomes will be 2 raised to the power 8, because for every every tossing of the coin we have 2 outcomes and we have been tossing the coin 8 times. So we have 2 raised to the power 8 outcomes, and when there is no head, there is only one outcome which does not have any head. It's tail, 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 all the 8 times tail. So there is only one possible outcome out of the 2 raised to the power 8 outcomes. And there is only one possible outcome when there is no tail. It's when all the coin shows head. So it is also 1 raised to divided by 2 raised to the power 8. So it is 1 minus 1 by 2 raised to the power 7, which is 2 raised to the power 7 minus 1, 2 raised to the power 7. So this is the probability of getting at least one head and at least one tail on tossing of the 8 coins. The next question, let E and F be 2 independent events and the probability of E intersection F is this and E complement intersection F complement is 1 by 2. We have to find probability of event E divided by probability of event F. Let's say probability of event E is X and probability of event F is Y. Okay. So probability of E intersection F is, these two are the independent events. So we have probability of E multiplied by probability of F. So which is equal to X multiplied by Y. So we have got that XY is equal to 1 by 12. Now comes probability of E complement intersection F complement. Since E and F are the independent events, E complement and F complement will also be the independent events. So it is equal to probability of E complement multiplied by probability of F complement. The probability of E complement will be equal to 1 minus X and probability of F complement will be 1 minus Y. It is equal to 1 by 2. So this implies 1 minus X minus Y plus XY equal to 1 by 2. And XY is 1 by 12. So what we get? 1 minus 1 by 2 plus 1 by 12 is equal to X plus Y. It is 7 by 12 equal to X plus Y. Now how can we find X minus Y? X minus Y is equal to under root of X plus Y whole square minus 4XY. because this is x square plus y square plus 2xy, and plus 2xy minus 4xy is minus 2xy. Now this becomes the square of x minus y whole square, and taking under root we get x minus y. So x plus y whole square is 49 by 144, and this is 4 by 12. So this is equal to 1 by 144 under root, or 1 by 12. So we get x minus y equal to 1 by 12. Now when x minus y equal to 1 by 12 and x plus y is 7 by 12, we get 2x as 8 by 12 and x as 4 by 12. So we have got x to be 4 by 12. So y is equal to 3 by 12 and x equal to 4 by 12. So now you have to find probability of E divided by probability of F, which is equal to x by y, and x is 4 by 12 and y is 3 by 12. So it is equal to 4 by 3. So this is not a probability, we just have to divide the probability of E and F. So don't get confused that it is coming out to be greater than 1. So the next question is, from a group of 10 men and 5 women, 4 member committees are to be formed, each of which must contain at least 1 woman. The probability for these committees to have more women than men is, so we have 10 men and 5 women, okay, and 4 member committees are to be formed, each of which must contain at least 1 woman. So total number of outcomes will be there should be at least 1 woman. So it's either 5C1 and 10C3, because 4 people have to be chosen. So if 1 woman is chosen, 3 men has to be chosen, or plus 5C2, 10C2, or either 5C3, 10C1, or either 5C4. All the women has been chosen. We cannot take the case when 5C0 and 10C4, because there the committee should have at least 1 woman. And this is equal to 5, and 10C3 is 10 factorial divided by 3 factorial and 7 factorial. So it's 10, 9, 8, 3 multiplied by 2. So it's 120, 5 into 120. This is 5 factorial by 2 factorial, 10 factorial by 2 factorial, 8 factorial. This is equal to 5 into 4, 5 to 10 multiplied by 45. And this is equal to 5C3 will also be equal to 10, and 10C1 is 10, and 5C4 is 5. So the total number of outcomes are 600 plus 450 plus 100 plus 5. These are the total outcomes. Now we have to find the favorable outcomes. The probability for these committees to have more women than men. So in all these 4 cases, for which of the cases we have more women than men? Here we have 1 woman and 3 men. So this cannot be possible. 2 and 2 not possible. Here we have 3 women and 1 man. So this case is the favorable case. And here we have 4 women and 0 men. So this case is also favorable. So favorable outcomes are 100 plus 5, 105. So probability is equal to 105 divided by, this is 1155. So this is the probability for the committees to have more women than men. Then the next question is, now if two different numbers are taken from the set 0, 1 till 10, then the probability that their sum as well as absolute difference are both multiples of 4. So how many of we have total outcomes? We have to choose two numbers from this set, and how many elements are there in this set? 11, because we are starting with 0. So total outcomes are 11C2, which is equal to 11 factorial by 2 factorial by 9 factorial. So it is equal to 55. So we have total number of 55 outcomes, and then the probability that their sum as well as absolute difference are both multiples of 4. So if we take multiples of 4, which are 0, 4 and 8, and if we choose any two from these three, like if I choose 0 and 4, their sum is 4 and difference is 4, multiple of 4. If I choose 4 and 8, their sum is 12, which is a multiple of 4, and their difference is 4, which is a multiple of 4. If I choose 0 and 8, their sum is 8 and their difference is 8. Both of are multiple of 4. So one possible case is 3C2 from these numbers. Next, if we take 1, 5 and 9, no, this is not possible, because 5 minus 1 is 4, but 5 plus 1 is 6, which is not a multiple of 4. So we cannot take these. Or we can take 2, 6 and 8. 6 plus 2 is 8, which is a multiple of 4. 6 minus 2 is 4, which is also a multiple of 4. So this is possible. If we take 6 and 8, 8 plus 6 is 14, which is not possible. And 8 minus 6 is 2, which is also not possible. And if we take 8, 6, 10. So 10 minus 6 is 4 and 10 plus 6 is 16, both of which are multiples of 4. And if we take 10 and 2, so it is 10 minus 2, 8 and 10 plus 2, 12. Both of them are multiple of 4. So we can take any two numbers from these three. So it's 3C2. So any other number won't serve our purpose of this. So we have favorable outcomes as 6. 3C2 is 3 and 3C2 3. 3 plus 3, 6 outcomes. So the probability is 6 by 55. So we have got this answer. So students, these were the questions from previous year JEE Mains papers, and these were very important questions, and keep practicing them. And that's all for today's class.